Hi guys, welcome back to my channel, and thank you for supporting me up to this point, and giving me your comments on the content that I share with you, because I'm really doing this content to make you feel ready by the time of the exam. Guys, I also just want to highlight that on the last lesson we've been doing November 2021 past paper. So on the last question, there's on my video, the last time there, I think I made a mistake of writing minus there instead of like plus. So it should have been plus. So but that doesn't answer, that doesn't change the point that I was trying to make there. I just made a mistake of writing minus. So hope you're enjoying this content. So today we're just gonna be focusing on November 2020. We're gonna do all those questions and then see how we can apply those principles that we have learned, right? Okay, thank you. Let's get to it. So I'm just gonna share with you the paper that we're gonna be looking at. So this is the paper for November 2020. In this question paper, there were only 2 questions on the number patterns. So most of the marks were on question 2, which is a combination of arithmetic and quadratic sequence. Let's get to it, guys. Let's look at what the question asked of us. So the first question was saying you're given a sequence there, which is 7xy and minus 11, and they told you that this arithmetic sequence. So remember what I said, every time they tell you the sequence is of particular nature, you need to be thinking about those characteristics of that sequence, right? Like in this case, we need to be thinking that, okay, the difference between consecutive terms should give us constant, constant difference or constant, and then which is the same common constant. And then we need to be thinking about Tn formulas that we've learned. We need to be thinking about Sn formulas, right? So the question asks us to determine the value of x and y. I'm sure at this point you're already thinking simultaneous, right? That's correct. We need to solve simultaneous equations using the characteristics of what arithmetic sequence to solve for this question. Okay, so I'm just going to open a whiteboard, then we can just dive into it. We were given 7xy minus 11, right? So we know for arithmetic sequence, that if I take t2 minus t1, that should give me the same answer as taking t3 minus t2, right? And similarly, t4 minus t3, that should give me the same answer as t3 minus t2. Okay. Then you can just let this to be, let's say, equation 1 and this equation 2, right? So if we substitute for actual values there, so then what you're gonna have is x minus 7 is equals to y minus x, right? So that's equation 1 again, remember? And then the second one we have, we're gonna have minus 11 minus y is the same as y minus x, right? Okay, so if we simplify these equations, let's just do this. So if you simplify these equations, so essentially you're gonna have, so this implies that, so if you take x, again, if you take y, x to the other side to make y subject of the formula, you're gonna have y equals to x when it jumps, gonna be 2x minus 7, right? That's your equation 1 there. And then so for this one, so we're gonna have you can make you can just combine the like terms. So if you take y to the other side and take, actually you can just take the x to the other side and move everything to the right. So then that means you're gonna have what do you call it? You're gonna have minus 11 plus x. Okay, actually, no, don't move x, sorry. Let's just that we have. Yeah, so essentially x, you move x and then, yeah, actually let's just move x because, yeah, y, okay, no, we have y there. So let's move everything to the left. And then so that, okay, let's move x to the left and then move everything on the left to the right. So then you're gonna have x equals 2. Remember, x1 is jump the equal sign, it's gonna be negative, and then that's gonna be 2y plus 11. That's equation 2, right? Okay, so at this point, so you can solve, yeah, you can solve for x and y by either substituting y into equation 2. In other words, you substitute 2x minus 7 for y, and then you solve for x, or you can substitute 2y plus 11 into 1, and then solve for what? Solve for x. Okay, so I'm just going to substitute equation 1 into 2 in this case. So if we sub 1 into 2, right? So if you substitute 1 into 2, then you're gonna have yeah, x equals to 2. Let's just try to write neatly. Yeah, so you're gonna have 2. What's y? Y is, remember, we're substituting y, which is, okay, 2x minus 7. That's 2x minus 7 plus 11. This is what we substituted for y, right? Which is y equals to 2x minus 7. This is equation 1. Equation 1. Okay, so then, yeah, if you simplify here, so you're going to have 4x minus 14 plus 11. So that's the same as 4x minus 3, right? So essentially at this point in time, so this must equals to x. So what you need to do, then we need to bring the like terms together. So if you take 3 to the other side, and then x, so you're gonna have 3 equals to 3x. Therefore, x equals to 1, right? Because you just divide by 3 both sides. Okay, and then once you have x equals to 1, then now you just need to substitute x into that equation there, and then solve for y. Therefore, y is gonna be 2, 1 minus 7, right? Because substitute x for y. So that's equals to minus 5. Okay, therefore x equals to 1 and y equals to minus 5. And those are the answers. Okay, so then, yeah, we can just go back and write down our solution. So that's gonna be yeah, that's equals to 1, this equals to minus 5. 4 marks, simple as that. Just combination of simultaneous equation and the characteristics of what arithmetic sequence. Okay, so now let's look at the second question. The second question will say you are given a quadratic number pattern, minus 3, 6, 27, and 60. Again, we need to be thinking about the characteristics of quadratic number pattern. We know that the second difference has to be constant. The first difference, it gives us arithmetic sequence. Yeah, because like knowing those in your mind or having those at the back of your mind, it just makes it easy to solve the questions, right? Without thinking too hard. Okay, so yeah, so in this case, so here they say determine the general term in the form of this. So we need to determine Tn formula for quadratic. Yeah, so for us to do that, so we need to let's write down this in our board. Right. So yeah, so we have what's our sequence? Our sequence is minus 3, 6, 27, and then 60, right? So the question wants us to determine Tn formula, right? Tn formula. Yeah, the question wants us to determine Tn formula. So Tn formula, Yeah, so Tn formula. So Tn formula that the question wants us to determine. Okay, so Tn formula that the question wants us to determine. It's so yeah, for us to determine the Tn formula, we need to solve three equations that we've discussed, right? Remember the three equations. So the three equations is so 2a must equals to the second difference, right? The second difference. And then the other equation is 3a plus b must equals to the first term of first difference, right? Right? And then the second equation is a plus b plus c must equals to the first term of sequence. The first term of sequence, right? Okay. So if we then take these principles, so just to try to apply them into our number pattern there, right? So so if we just do this, right? So yeah, so if you look at that, so actually let me just write this number pattern here because I'm not gonna have a room. Okay, so yeah, if you look at the differences, the first difference 6 minus 3 that give us 9 because it's 6 minus 3, right? And then this minus this that give us 21, this minus this, okay, 27, 28, like, yeah, I mean, so this is 60, but yeah, it's 68. So guys, this is 60. Okay, so excuse me for that. So okay, so this is 60. Excuse me, that's 60. Okay. So yeah, then 60 minus 33, right? That's 33. Let's make things consistent. Right, so yeah, that's 33. Okay. So and then if you minus this is gonna be 12. This is 12, right? Okay, so essentially, so we need to cycle this because this is very important terms, right? So what we mean is that so this is the second difference that we're talking about, right? The second difference, that's the second difference. And then this is the first term. This is the first term of the first difference that we're talking about. So that's gonna be mapped with what? That's gonna be mapped with this guy here, right? And then the first term is gonna be mapped with this guy here. Those are very important. Those are very important. So essentially, then what you're gonna have is, so 2a is gonna equals to 12. Therefore, a equals to 6, right? And then so if you substitute a for 6, I mean 6 for a there into this equation, then you're gonna get 3, 6 plus b must equals to, what's the first term? The first term is 9. The first term of the first difference is 9. Therefore, then you solve for, we solve for b. So for b, therefore b is equals to 9 minus 18. Okay, so that's minus 9. Okay, and then so then the last one to solve for is it's this guy here, right? So that guy there. So we're gonna have, or a is 6, and then b is minus 9, and then c is what you're looking for, and then the first term is minus 3. Therefore, this implies that 6 minus 9, so that's minus 3. Then you take minus 3 to the other side. You take minus 3 to the other side. So then that means that c equals to 0. Therefore, Tn, so our Tn formula then is going to have to be, 6n squared minus 9. Okay. yeah, let's just make sure that, this is indeed correct as we were asked to show, right? So, okay, now they actually were asked to determine the Tn formula. Okay, yeah, so then that's Tn formula that you're gonna have. So a Tn formula is gonna be, Tn is gonna be 6n squared minus 9n. That's the answer. Okay. So once we have Tn formula, so they now calculate the value for 50th term. So now they want us to determine T50, right? So for us to get T50, so we just need to substitute 50 into n there, right? Into n. If we do that, so that's gonna be, that's gonna be, so T50, that's gonna be equals to 650 squared minus 950, right? So then you can just punch quickly in your calculator. So squared minus minus 950. Then we have 14550. Okay. So yeah, then that solves the question, right? That solves the question. That solves the question. So that is 4550. Okay. So then yeah, then the question say show that the sum of the first and show that the sum of the first and first difference of this pattern can be given by this. Remember, we said that the first difference, the sequence formed by the first difference of quadratic is arithmetic sequence, because when you take the difference of that sequence, you get constant. So which means then what they're asking us here is to derive the SN formula for the first differences sequence. That's quite a mouthful. Okay, so let's see what they want us to do. So if we go back, so we need to look at our first difference formula, right? Okay, so this was the first difference number pattern. So they want us to determine SN for this guy, for those guys, right? So if we do that, so if we go, so we have, let's write it down, 9, 21, 33. That's a sequence of what? That's a sequence for first difference. And we know that this sequence must be arithmetic, right? So which means we need to use SN for arithmetic sequence, to derive or to prove what they're asking us to show. Okay, so if we go back, so if we try to find the difference between these two, remember we know that that's 12, right? Okay, so, and then we need to apply SN formula, which is n over 2, 2a plus n minus 1b. Okay, so n is like, yeah, so we need to substitute for value for what? We need to substitute the value for a and d. So a, remember, is the first term in the sequence, and then d is the constant difference. So then if we substitute that into SN formula there, then you're gonna have n over 2, the 2 times, what's a? 9, and then the plus n minus 1, what's d? D is 12. So if we simplify that, so that's gonna be n over 2, that's 18, 2 times 9, 18. And then if we do the math here, so 12 times n, so that's 12n minus 12, and then minus 12 plus 18, so that's 6, right? So you have 12n plus 6. Then if you simplify this, so you're gonna have 6n squared, and then so you're gonna have plus 3n. Okay, so then yeah, let's check if this is the same as how they want us to prove that sum of the first n terms of the first difference equals to that. So if you go back to the question, yes, that's correct, right? That's correct. Okay, that's easy 3 marks. Okay. And then, the last question was asking us, they say, how many consecutive first differences were added to the first term of the quadratic number pattern to obtain the term in a quadratic number pattern that has the value of 2106? Yeah, how many consecutive first differences were added, to arrive at this guy, right? So to arrive at this guy. Yeah, this is quite interesting question. So you need to be very careful. So firstly, I just want to open a whiteboard, and then let's see how we can address that question. Right? So yeah, let's try to derive a small sequence, and then let's see the pattern, and then we can apply that. Right? So let's suppose you have a sequence. And that sequence is that so you had -3, you had 6, you had 27, then you had 60, right? Okay, and then you had 9, 21, 33. Right? Okay, so and we know that this is arithmetic sequence, right? So we know this is arithmetic sequence. Okay, so let's look at this. So for us to move from -3 to 27, then this is the same as what? It's the same as saying that -3 plus S2 give us 27, right? So essentially, yeah, -3. So we always start with the first term plus 2 terms, because if you look at this, -3, you add 9, you get 6, and then 6, you add 21, you get what? You get 27. So essentially, if you're adding these first 2, differences, but those 2 differences are what? Are arithmetic sequence. So which means then in this case, they're asking us, they want us to determine, the S, how many terms, how many first difference, how many of these guys are we adding to get to that term that they mentioned. The term is 2106. Let's just confirm. 2106. Okay, yes, that's correct. Yeah, so essentially, so they want to know that, how many of these guys do we have to add? How many of these guys do we have to add such that, we get this guy? So essentially, what you're trying to solve for is -3 plus Sn must equals to 21060. Because summing these guys is like Sn for arithmetic sequence, because these guys, they form arithmetic sequence. So for us to solve this, we need to determine how many Sn formulas, right? So how many Sn do we need to get to solve for this, essentially, right? So, and we know that for Sn, so if you just go back, if you go back to the formula that we just derived right now. So remember, we derived that Sn was equals to 6n squared plus 3n. I think that's what we derived, right? That's what we derived for. Let's just check on the second question. Yes, that's what we derived. We derived that this is the indeed Sn formula, right? So if we solve for this equation, so if we say -3 plus 6n squared plus 3n, right, equals to 2160. 0, 6. So this should give us the answer that we're looking for. That should give us n, which means it's going to tell us how many of these guys we're going to be adding for us to get what? For us to get to this value here, if that makes sense. Okay, so then we take this guy to the other side. So you're just going to have 6n squared plus 3n mass equals to 21060. So let's just make sure. Yes, okay. So yeah, for us to solve this, so remember we have 6n squared plus 3n minus 21060 equals to 0. So yeah, I mean the easiest way for us to solve for this, for n in this formula, then that will be using quadratic formula, right? Quadratic formula. So you know the quadratic formula says that x, okay, let's just write it down first. Minus b plus minus square root of b squared minus 4ac equals to 2a. That's the formula that we need to use in this case, right? So if we apply this formula into our scenario, then you're gonna get n equals to, what is a? So I mean b. So b is minus 3 plus minus 3 squared minus 4 was a, 6 was c minus 21060, right? Divided by 2 6. Yeah, so essentially you're gonna get n. So let's see. You're gonna get two answers. You might get the other one that's negative, the other one that is positive. So remember, since you're dealing with the number pattern, so n cannot be decimal, n cannot be negative, n can only be positive. So if you get, let's say, 2. Just give it 2.3, then which means you convert it to the nearest, integer, which is gonna be 3 in this case. So you cannot have n being, you cannot have n being you cannot have n being what do you call it, being you cannot have n being a negative number, right? Okay, so let's see if you solve for that. Minus 3 okay, so the positive end that I get is 58, right? 58.999. Okay, so let's just try to apply a logic here, right? Let's try to apply the logic. So the question says how many, of the first differences that needs to be added on the first term to get what? To get to this guy, right? So if n equals, so which means it's telling you that n, n is somewhere between 59 and 58. That's what this tells you. It's telling you that the correct n is, it's between there, right? But then if we're gonna use n equals to, 58, 59, that's probably gonna lead us to, the answer is gonna be more, right? The answer is gonna be more. So the correct answer here, I think we're gonna have to take like the first n, which is 58, right? So which means your n is gonna be approximately 58. So if you're going to add 58 n terms in this sequence to minus 3, you're gonna get what? You're gonna get 216. Because if you're gonna use 59, then that's gonna be more than that guy. That's gonna be more than that guy. I hope that makes sense. Okay. So now let's look at the other question. So the follow-up question was, okay, that was the last question actually. Okay. So let's see the second question. So the second question, was question 3. So they will say like you're given sequence there, or it's a convergent geometric series. Sure. Okay, so they say prove that that is convergent geometric series. They already told you that's a geometric series. And remember in the video we covered what it means for geometric series to be convergent. So geometric series is said to be convergent if the ratio, right? If the ratio is between -1 and 1. So if R is between this, then like that series is convergent. So essentially we just need to show that R for this sequence is between -1 and 1. Then we will have proved the answer, right? Okay. So there's going to be a bit of exponential characteristics or properties that you need to apply to modify this formula, right? We need to modify this formula. We need to write it in such a way that is in the form Tn a r n minus 1. Because if you can write it in this form and then prove that r is between these, then we solve the question. Right? But at the moment, like it's not at the form that allow us to inform if r is between -1 and 1. So we need to convert it first to here. Okay, so let's see if I'm just going to open a whiteboard. So maybe we can just write here, it's fine. Okay, so we have 4, 3, 2 minus k, right? So if we want to write this thing in this form, so we can write this as, say, 4, and then 3, if you take 1, 3, right? If you take 1, 3, and then write this as 3, 1 minus k, essentially, right? Remember, this is just 1. So then we can simplify this further and be like, okay, yeah, 3. So we need to make this thing to look like k minus 1, right? We need to write it in this form. So if we do that, so for us to do that, so you can write this as 3, -1, k minus 1, essentially. So if you write it in that form, then we're able to remember the loss of exponents, here. So this can be written as what? This can be written as 4, 3, 3 to the power of -1, then all over way brackets k minus 1. Okay. So now we've written, because remember, like the loss of exponent allows. So now we've written our formula in this form. So which means this guy, 3 to the power of -1, that is the common ratio, because now we managed to write it in this form. So a equals to 4 times 3, and then this is a, and then this is r. So but then when it's like that, it's not very helpful. So if we know that 3 to the power of -1 is the same as 1 over 3, right? So which means then your formula, I'm just going to open a whiteboard. So your formula is going to be, T, okay, so it's going to be 4, 3, 2 minus k is the same as what? It's the same as 4, 3, 1 over 3, k minus 1. That's the same as 12, 1 over 3, k minus 1. Therefore, this implies that, so r is between 1 and -1, because r in this case is 1 over 3 and implies this. Therefore, you prove that this is convergent, right? It's convergent. Because we managed to show that this principle is met. The key was just to transform like that form into this form, that into the form of to prove that. Okay, so let's go back to the question. If we go back to the question, so so yeah, the second question was asking us, let's just clean this a little bit. So it was asking us, show that yeah, show that, you know, show that sum of this is equals, okay, no, sorry, if this is sum of this equals 2 over 9, determine the value for P. So yeah, remember what this means, it means that you're just summing these guys starting from P upwards, right? So if P is 1, then this is the same as sum to affinity, right? Remember, yeah, if P is 1, that this is the same as, like, you know, sum to affinity, but P can be anything, so we don't know what P is. So we're going to sort of try to trick this question to try to solve it in a way that, you know, can be able to determine the value for P. So how I will go about it is to say, okay, so if, let me just write here before. So we know that infinity k equals to 1 is the same as what? Is the same as k equals to 1 to p minus 1 plus k equals to p to infinity. Right, so essentially you just broke that sequence, you just broke it into what? Into parts. So they already gave us the value for this, right? So we just need the value for what? For this guy, for this guy. So to get the value for this guy, remember we can use what? You can use SN formula for this sequence. And then this is the same as P minus 1, essentially. We're summing what? The first P minus 1 terms for this sequence. If you can get that and combine it with this guy. And then remember, we can derive this guy, right? This guy is the same as affinity, which is A over 1 minus R, right? So we know the left-hand side is sum to affinity, which is A over 1 minus R. And then we know this guy, right, which is what is given, which is 2 over 9, right? 2 over 9. So yeah, we just need to solve for this guy and the middle guy. Okay, so let's see. So if we open our whiteboard, so we know that, so yeah, we know that, so just do this. Okay, so like before we go to another page, so from here, we can tell that, so from here, we can tell that, so A equals to 12, R equals to the 1 over 2, and 1 over 3, sorry, for this sequence, right? So these are very important. You're gonna need them for what? For S affinity and SN formula that you're gonna use in the next page. So just to write down what I was saying in the other page. So we're saying that Sk equals to 1 to infinity of 4, 3, 2 minus k is the same as k1 p minus 1 4 3 2 minus k plus kp infinity 4 3 2 minus k, right? So this one we know is equals to 2 over 9 because they told us. And then this one we know that is equals to S affinity, so which is A over 1 minus R. What is A? So remember we simplified this guy in the form of what? In the form of 12, 1 over 3, k minus 1, right? So this is A, and then R is 1 over 3. So we have 12 over 1 minus 1 over 3. Okay, so then this is gonna be, so 1 minus those, that is like 4 over 3. Then sorry, so 2 over 3 I mean to say, so that's 12 over 2 over 3, because that's gonna be 1, which is, yeah, 2 over 3. So that is the same as multiplying what? Multiplying 12 by 3, So if you just punch, yeah, from here, actually just punch your calculator to avoid wasting time doing what I'm doing. I'm just trying to solve it in my head. So here, like you're gonna have 3 times 12, that's 36. 36 divided, that's 18, right? The answer is gonna be 18. 18. Okay, so then now, so we need to solve for SN formula. So SN for geometry, we know SN equals to A R minus 1 over R minus 1. But we know that A is 12, R is 1 over 3. What's N? N is P minus 1 in this case, because we need S P minus 1. For this guy, for solving this guy. So that's gonna be P minus 1 and then 1, right? So divide by what's R, 1 over 3 minus 1, right? So then like, yeah, if you continue, that's gonna be minus 2 over 3. So minus 2 over 3 times, yeah, minus 2 over 3 over 12, that's minus 18. So you have minus 18, 1 over 3 P minus 1 minus 1, right? So if you multiply inside the bracket, so you're gonna have 18 1 over, okay, so it was minus 18 1 over 3 P minus 1 plus 18, right? Okay, so we have 18 on the left hand side, which is S affinity. And then we have this guy, which is the middle term, and then we have 2 over 9, right? So then let's just try to solve that for that. So I'm just going to write it down. So therefore it's going to be 18 equals 2 minus 18, 1 over 3 to the power of P minus 1. And then, so let's go back, plus 18. Yeah, plus 18 plus 2 over 9, right? So let's just circle this term so that you understand where each is coming from, right? So this is S affinity, right? And then this is S affinity KP times 4, 3, 2 minus K. And then this is just like, the middle term, which is K equals to 1, P minus 1, 4, 3, 2 minus K. So essentially we split S affinity into those two parts, right? So now we need to solve for P. So this cancel with this guy, obviously. And then, yeah, and then like in this, you can just take, you can take this guy to the other side. So you're gonna have minus 2n, minus 2 over 9. Then you divide by minus 1 over 18, let's say. Because you multiply by minus 1 over 18 on both sides, right? Both sides. Then you're gonna have 1 over 3 P minus 1. Right? So if you multiply these two guys, then you're gonna get 2 over 8 times 9. So let's see. Okay, so then the answer here, so this implies that you're gonna have 1 over 81 equals to 1 over 3 P minus 1. So let's write distance as a base of what? As a base of, so as a, remember the root to the power of 4 is equals to 81, right? 3 to the power of 4. Yes, so you're gonna have, to solve for this, so you're gonna have, this is the same as, so this guy is the same as 1 over 3 to the power of 4 equals to 1 over 3 P minus 1, right? So yeah, from the laws of exponents, you know that P, this means that, I'm just going to take it here. So this means that 4 must equals to P minus 1, right? because like the bases are the same, so the exponents has to be the same. Therefore, this implies that, P equals to 4 plus 1, which is 5. Okay, yeah, then that solves the question, right? That solves the question that, we're trying to get the answer for. So P must equals to 5. Okay. Yeah, then that brings us to the end of our November 2020 number patterns questions. Yeah, thank you guys for watching, and yeah, I hope you found this very insightful, and helps you to appreciate some of the concepts that we've learned so far. So yeah, if there are any questions that you have attempted on the number patterns that you want me to go through with you, please feel free to share them with me. I will try to attempt them with you, and then yeah, we can see where you might be struggling or where you need help. Okay, yeah, see you on the next video. So the next video, we're gonna be looking at either the functions or like, the financial maths, right? So I think the functions are more likely to be the next video, given that there's quite a lot of marks on those questions. So I want to focus more on the chapters that they have a lot of marks, and the examiner, they ask a lot of questions on that. Okay, thank you guys. Thank you very much for watching this. And please don't forget to like and subscribe if you find this stuff very useful, and comment if you have any questions. Thank you.